Okay, this is a lesson on solving rational equations now. Okay, so what is a rational equation and how do we solve them? So rational equations are equations that have at least one rational expression. So in other words, a fraction. So you'll notice here's a fraction, and we want to be able to solve these. Okay, so how do we do that? We're going to use some of the skills that we've learned in this unit to do that. Okay, so take a look at these two students, and they've solved the same equation in two different ways. You can see the work below. Okay, so this student, it appears, right, has solved just using fractions, and they got x equals 1. This student here got rid of the denominators so there were no fractions by multiplying everything by 10. And then they ended up with this equation, which looks significantly easier. And then they solved and they still got 1. So probably a lot of you would prefer Tavan's method a little bit more. Okay. So to solve rational equations, you want to try to get rid of the denominators. And the way that we do that is we multiply all the parts by the least common denominator, also known as the LCD. Okay, so in this particular case, I would say, all right, well, I want to get rid of x plus 4. I'm going to multiply everything by x plus 4. So that means I'm multiplying this side of the equation, I'm also multiplying this side. So if I multiply this by x plus 4, these two are going to cancel out, right? So that's the purpose. So I would really end up with this, and then this. So then these would cancel, right? And I'd be left with 1 equals, and I distribute this out. And now I should be able to solve. Okay, so I would subtract 8 from both sides. And then divide by 2. So that would give me negative 3.5 if you want it as a decimal, or negative 7/2, however you want to do that. But that's now a little easier than trying to figure that out. It's easier to get rid of that denominator. So this is how we solve rational equations, whether they're relatively simple like this one, or they get a little bit harder. Okay. So let's try one that's maybe a touch harder, and see if this makes sense to you. So you'll notice here I have a denominator in this one of x minus 4. I also have a denominator of x right here. So these are my denominators. So really my least common denominator would just be x times x minus 4. So what I want to do is I want to multiply everything by x times x minus 4, because that will cancel out all denominators. So I'm going to write it out so you see what we have. So if I multiply everything, and I won't always write out every single thing, but this first time, so in the top, if I multiply this first by that, I would get this. And then if I multiplied the 4 by x and x minus 4, I would get this. And then over here, right, I would get this. Okay, so now normally you probably wouldn't write all of this out, but I want to do this the first time to just show you what cancels out. So write this and this cancel. Okay, in the 4, I don't have anything in the denominator to cancel, so that won't happen. But over here, the x and the x would cancel out. And now I have no more denominators. So right here, I have x times x minus 3 at the beginning. So I want to use that and simplify that. So that would be x squared. If I distribute what's left, right, go this times this times this, I get that. This I would have 4x times x, which would be 4x squared. And then 4x times negative 4 would be negative 16x. And then right here, I would have 3x squared minus 12x. Okay, so now I just want to do a little simplifying and make sure that it works, right? So we're going to simplify some stuff. Okay, so let's see, I got 5x squared. This will be negative 19x. Okay. Cool. Now I'm gonna move the 3x squared to the other side. So if I subtract 3x squared from both sides, I'd get 2x squared. And then I'd want to add 12x to both sides. So that would cancel out. This is canceled out now. I'd have negative 7x. And that equals 0. All right, probably to solve this, I'd want a factor. Whoops. I want to take out a 2. I'm going to take out an x, not a 2. Okay, so what values for x make this equal 0? Well, when x is 0, right here, right? And then the other one would be when x is 3.5. Like, well, where did that come from? If I take this part right here and set it equal to 0, right? Solve that. Add 7. Divide by 2. Look at that. So these are my two answers. Okay. Hopefully that makes some sense. There's a little work involved in some of these sometimes, and sometimes everything drops out and it's a lot easier. So it really kind of depends. Okay, let's try maybe one more of these to just make sure that you feel pretty good. Okay, here we go. Well, let's see. This one is factored to, I'm going to factor this denominator. Okay, so really this is my least common denominator, my LCD. So I'd want to multiply everything by that. So if I do that, I want to multiply everything by x minus 4 times x minus 1. Okay, so if I do that to the first one, this fraction, the x minus 4 on the bottom is going to cancel out with the one in the top. So I won't write out the whole thing here this time. So I would be left with x plus 6 times x minus 1. Okay, this one, if I multiply, the numerator and the denominators would cancel, so I would just have 30. And then over here on this side, the x minus 1 would cancel out, and I'd be left with x minus 4. Okay. Well, now I just do some distributing, combining like terms, and hopefully I can solve pretty quickly. So let's start here and distribute. X times x is x squared. X times negative 1 is negative x. 6 times x is 6x. And 6 times negative 1 is negative 6. And then minus 30. Over here, we'd have 3 times x, 3x. 3 times negative 4 is negative 12. Okay, simplify. I'd have x squared plus 5x minus 36 equals 3x minus 12. So I'm going to subtract 3x from both sides. And then I'm going to add 12. If I add 12, this will be negative 24. Okay, so now I need to factor that. Probably is the easiest way to solve and set equal to 0. So this would be positive 6 and negative 4. So then what does x equal? It would be negative 6 and 4. Those are my two answers. Okay. Hopefully that makes sense to you. Okay, so one thing that I haven't addressed yet, but actually you need to be considering every time you do one of these problems, is something called an extraneous solution. Now, extraneous solutions are solutions that would make the function undefined because they are not part of the domain. So what does that mean? Well, let's look at this problem right here to help us figure that out. I know that this x squared minus 4 part would factor to x plus 2, x minus 2. Okay, now even before I start this problem, I probably would say something like this. I know that x in this problem cannot be equal to 2 or negative 2, because that would make denominators equal to 0. So it's smart whenever you do these to start by writing that. We didn't do that for the first couple problems because I just wanted to get you used to how these problems work, but you should always do this kind of moving forward. So I start by writing this, and then when I get to the end, I'm going to check with this and make sure my solutions are not that. Okay. I think I'm just going to move this a little bit so I got some room. Okay. Now let's do... I'm going to do blue here. I'm going to multiply everything by my common denominator, my LCD would be x plus 2, x minus 2. Okay, so, all right, this first one, the x plus 2's would cancel, and I'd be left with 1 times x minus 2. Okay, in the second fraction, my x minus 2's would cancel, and I'd be left with x plus 2. And in the last one, the denominator would cancel altogether, and so would the numerator, so we're good. Okay, so that's what I'm left with right there. So now I'm going to simplify. So I get 2x equals 4, so x is 2. Okay, but now let's look at my answer here and then go back here. Remember, we said that x can't be 2 or negative 2, and we just got the answer was 2. So this cannot be a solution. And I also don't have any other solutions. Like sometimes you have 2 or 3 solutions. In this case, we only have 1, and it can't be it. So my answer is actually no solution. There isn't a way to make this work. Okay, so that's how you look for extraneous solutions. You should always try to do that on every problem to just make sure that you don't get yourself into any trouble. I want to do one more, and then we're done. Okay, so this one factors to x minus 5 and x minus 3. Okay, so that will be my LCD again. Okay, So now I'm going to go back and I'm going to say, well, this first one, the x minus 5 would cancel. I'd be left with x minus 3. This one, the x minus 3 would be canceling out, so I'd be left with this. And then this one, the whole denominator would cancel and the numerator, so I'd be just left with 2. So now I'm going to simplify by distributing. Okay, and I get that. I still need to simplify. I get x squared. X minus 5x would be negative 4x. And then the negative 3. Okay. Subtract 2 from both sides to set it equal to 0. And I would get negative 5. All right, so now I would just factor that. One thing I forgot to do, but we'll do it at the end this time, is say what x can't be. Okay, so I factor this out, I get negative 5 and positive 1. And then that means my answers would be 5 and negative 1. Okay, but now if I go back here, I should have written what x can't be right away. So x cannot be, right, if I look at the denominators here, x couldn't be 5, and it also can't be 3. Now, if I go down here and look at my solution, I notice that one of my answers is 5, and that's what I said right here that I can't have. Okay, so this right here is not a solution, but I still have one left. So this is my answer. My answer would be x equals negative 1. But 5 is not a solution. It's an extraneous solution. So that's how you do those. Just, again, it helps to write this out first and then go back and just check your answer and make sure all your solutions are okay. All right. That is how you solve rational equations. Go ahead and give the assignment a try. And don't forget to write it into your planner. Good luck.